All right, so we are going to go on to trigonometry of right triangles now. Okay, and this is really kind of the basis of all trigonometry, because trigonometry really, the definition is like the study of triangles. Okay, so we're going to talk a lot about triangles today. And we're going to talk about SOHCAHTOA. All right, so you guys probably remember this from geometry. In fact, a lot of what we're going to be doing this year is from geometry, the stuff you learned in geometry. A little bit of stuff that you may have learned last year, although it would have been at the end of the year, and I know that was kind of when things got crazy last year. So I'll definitely kind of introduce this as if it's kind of the first time, okay? Okay, but SOHCAHTOA is from geometry, and it's a trick for remembering the three basic trig functions. You could put trigonometric there, but trig is a good popular abbreviation for that. And so these are the three basic trig functions. There's actually 6 total, but the 3 basic ones are sine, cosine, and tangent. And even though those are the most basic ones, they're actually also, I would say, the most important ones, the most useful ones as well. So S-O-H, it stands for sine equals opposite over hypotenuse. Ka, C-A-H, is cosine equals adjacent over hypotenuse. And then TOA is tangent equals opposite over adjacent, okay? All right. So then we also have our, these ones over here, which are called the reciprocal functions, And so they are the reciprocal of one of these. So our first one is called cosecant, abbreviated CSC. So cosecant is the reciprocal of sine. So that is hypotenuse over opposite. Remember, reciprocal means flip the fraction, right? So a lot of people say that cosecant is the opposite of sine. I don't like that terminology, because the opposite of sine would be negative sine. Like opposite in math means switch from positive to negative. So this is definitely more accurately called the reciprocal of sine is cosecant, which means we just flip that fraction, okay? All right, next up we have secant. Secant, which is abbreviated SEC. So that is the reciprocal of cosine. So it's going to be hypotenuse over adjacent. And then lastly, we have cotangent. Cotangent as the reciprocal of tangent would be adjacent over opposite. Okay, now before we move on, usually when I teach this, okay, so people have a problem with the names over here, especially secant and cosecant. A lot of people would say, hey, Mr. Barry, shouldn't it be that secant is the reciprocal of sine and then cosecant is the reciprocal of cosine? That would make more sense, wouldn't it? And I would actually kind of agree with that. So I actually looked up, like, why is secant the reciprocal of cosine and cosecant is the reciprocal of sine? And so what I found out is, so sine, cosine, and tangent are very old, okay? The ancient Greeks were doing these over 2,000 years ago, sine, cosine, and tangent. Then they came up with a new measurement for, like, it's complicated, but for a triangle within a circle, and they named that measurement secant before realizing that it was the reciprocal of cosine. So they found this new measurement in a triangle within a circle, named it before realizing it was the reciprocal of cosine, and then they're like, oh man, that's the reciprocal of cosine. But then they're like, but we can't change the name though. We have to keep it as secant, okay? So then they kept it as secant, and then they're like, okay, well, I guess then the reciprocal of sine and tan are important as well. So let's give those names. And so they did. So that's my story. If you care about the history of why this is called secant, I did look it up and that was my explanation, okay? Awesome. All right, so now we're gonna start find some missing sides and angles. So again, this should be a review of geometry here. All right. So we have our angle theta here, which we've often been using the variable theta to represent an angle. And so the first thing we would want to do is identify all the sides as opposite, which one's opposite, which one's adjacent, which one's hypotenuse. So I find that people, if they have trouble with this, have trouble identifying the adjacent side. So what I would say is, let's label the other two first, and then the one that's left over is the adjacent. So if you shoot an arrow out from your angle, and it does depend on which angle you're looking at, but if I'm looking at this angle, I shoot an arrow out, this will be my opposite side. If you shoot an arrow out from the right angle, you'll hit the hippopotamus. No, just kidding, the hypotenuse.
My goodness.
And then by default, the last one that's left must be the adjacent because that's the only option left, right? So that's how I label my sides. Okay, so now to find this angle, find angle theta, we're going to need to use either sine, cosine, or tangent. Now, how do I choose which one of those I'm going to use? Well, what information do I know? I know about opposite and I know about hypotenuse, correct? I don't know anything about adjacent, so my two known sides are opposite and hypotenuse. So which one of these three, the main three, is what we're going to be looking at here. Which one of the main three uses opposite and hypotenuse? Oh, that would be sine, correct? So I'm going to use sine here. So I'm going to say sine of theta equals opposite over hypotenuse. Okay, so whenever we need to find an angle here, we need to get rid of that sine. You're not allowed to just divide by sine. That's not a thing. That would be like dividing by log. It's not really sine times theta. So that's why we don't divide it. It's theta inside of this thing called sine. So how we get rid of a sine is by doing sine inverse. So for this, I would say theta equals sine inverse. And sine inverse, we show with a little sine -1, 8/16. Okay. The inverse being the looking like a -1 power. That's kind of similar. We used to do like f inverse of x. Remember we did that, f inverse of x, back in the day, a few months ago. All right, so from there, I want to do this on the calculator. Now you'll notice in the instructions here, they want the answer in radians and degrees. So we're going to talk about that. So I'm going to go ahead and use Desmos for my calculator here. So I'm going to grab the calculator right there. Okay. And so I'm going to do sine inverse. So if you bring this up and go to functions, you'll see sine inverse right there. You actually have all 6 inverses and all 6 regular functions. So we'll do sine inverse of 8/16. And that comes out to 0.52, okay? Now, I'm going to verify this in a second, but I'm going to ask you, if you were to guess, is that answer in radians or degrees? Does that angle look like it's 0.52 degrees? I would actually say no, that angle does not look like 0.52 degrees. It's like half of a degree, right? That would be such a small angle that I don't think that's possible. So then I think that this answer is in radians. Well, how do I verify that? Well, every calculator that does sine, cosine, or tangent has somewhere to change the mode from radians to degrees and vice versa. On Desmos, it's this wrench up here. If you click on the wrench in the top right, you can see on the bottom here, it says radians or degrees, okay? Right now, you can see that radians is highlighted. So that means that this answer is in radians, okay? So that's okay. We do need the answer in radians. So I'm going to go ahead and write this down. I'm going to say theta equals 0.52 radians. but I'm actually going to go back and I'm going to do this again using degrees. Now, when you were in geometry, your geometry teacher probably told you, make sure your calculator is in degree mode. You should always be in degree mode or you're going to get wrong answers, okay? I'm actually not going to tell you that anymore because we're actually going to be doing some problems in radian mode and some problems in degree mode. So which mode is correct? Well, it depends on the question. Are we talking about radians or are we talking about degrees? If we're talking about degrees, we should be in degree mode. But if we're talking about radians, we should be in radian mode. In this question, it asks for both, so we need to use both. So watch while I switch this over to degrees. And you can see this answer changes to 30 because now it's 30 degrees, okay? So what if you're not using Desmos? What if you're using your own scientific calculator? Well, like I always tell you, I can't go through everyone's calculator and show you how to do this, especially since you guys mostly aren't here on campus. If you are on campus, I'd be happy to show you. But what you can do is just Google search your calculator model and then say radians to radian mode and degree mode, okay? And I'm sure that you can find a YouTube video or a website on how to do that, okay? All right, so for this one, we got 30 degrees. So 30 degrees or 0.52 radians. If I did convert this 30 degrees to radians, I think it would be 0.52, right? So if I said, what's 30? And then to convert that, we multiply it by pi over 180. Notice that we do get that 0.52 because that is the conversion, correct? So these two answers are actually the same. It's just different units of measurement. It would be like if I said, if the answer was like 6 feet and I said 6 feet or 2 yards. They mean the same thing, just using a different unit of measurement, okay? All right. We're gonna go ahead and skip number 2. It's kind of the same thing. It's another sine inverse. If you'd like to do that on your own, then feel free. But I'm gonna go ahead and move on here since it's a little bit redundant, okay? All right, next thing we're gonna do is solve triangles. So a triangle has 6 parts, 3 angles and 3 sides. To solve a triangle means to determine the lengths of the 3 sides and the measures of the 3 angles. So we're gonna do that a couple times here on numbers 3 and 4. Now the thing that jumps out right away to me on numbers 3 and 4, notice that number 3 is in degrees and number 4, the angle is in radians, okay? So that's what I was saying. We're gonna have to be flexible and be able to work with both. All right, so let's work on degrees first. So for degrees, I kind of always start off if they give me 2 angles, which they have given me 2 angles here because the 90 degrees is an angle. I know that a full triangle is 180 degrees. So if I subtract out the 90 degrees for the right angle, and then the 23 degrees for the other angle, then I know that this last angle would be 67 degrees, correct? Okay. Now, some people do a little shortcut for right triangles. And you know, for a right triangle, these 2 small angles will have to add up to 90. So they just do 90 minus the given angle. Do you think I'm okay with that? Yes, I am. So if you notice a right triangle, just do 90 minus that angle and you'll get the other angle. A little shortcut there. Okay, so now we got to find the missing sides. And so for that, I'm going to have to use SOHCAHTOA. So I need to pick an angle. I can either use 67 or 23. Either one's fine, but I just have to pick one and go with it. I'm going to choose 23. So from 23, this way is my opposite. I know opposite of the right angle is the hypotenuse. And that means that the 15 by default must be the adjacent. I'm going to go ahead and label my opposite side X and my hypotenuse Y. I just like to have a variable for them. It makes it easier when I'm doing the math. If you wanted to call the opposite side O and the hypotenuse H, I think that's fine. I actually don't like using O as a variable because it looks like a 0, right? So I don't like getting confused on that with my O looking like a 0. All right, so let's start finding missing sides here. So what do I want to find first? I can either find X or Y first. Doesn't really matter. I'll go ahead and find X first. All right, so what I'm thinking about here is I want to know the opposite side, and I do know the adjacent side, right? So the adjacent is known, the opposite is desired. What trig function has O and A? That would be tan, yes? So tangent of our angle, so this time our angle is known as 23 degrees, equals x over 15, which is opposite over adjacent. We are wanting to isolate x. So I'm going to go ahead and multiply the 15 over to that side. And so that I can just now type into the calculator 15 times tan 23. You actually don't need to put the 23 in parentheses, but I'll do it anyway. I want to double check here since that 23 is a degree. I want to make sure I'm in degree mode here, and you can see that I am. So this is now the correct answer in the degree mode. So we'll call it 6.4. How about that? 6.4 sounds good. Okay, so now that we know that this side is 6.4, there's actually several ways we could find the hypotenuse now. Since we know two sides on a right triangle, we could actually use Pythagorean theorem to find the third side. Little a squared plus b squared equals c squared if you like it. I'm actually more of a SOHCAHTOA guy, so I'm going to go ahead and use a trig function here. So I could use sine now because I know the opposite side. I want to know the adjacent, or I could use cosine since I know the adjacent and I want to know the hypotenuse. So I'm going to go ahead and use cosine. So we have cosine of 23 equals adjacent is 15. And then hypotenuse is y. Now on these ones, when you have the variable in the denominator, it's one extra step to isolate it, all right? So you're gonna multiply the variable, the y, over to the other side. And then you're gonna divide the trig function back over to the other side. So that's gonna be y equals 15 divided by cosine 23. All right, so we'll type that into the calculator. 15 divided by cosine of 23. I know I'm in degree mode because I checked it on that last one. So this answer looks good to me. We'll call it 16.3. All right. A quick note, if I filled all of these out on up here, so this one would be 16.3 and this one would be 6.4. A good kind of check for your work here on these always, that I always do. A good property about triangles is that the biggest side is always opposite the biggest angle. The smallest side is always opposite the smallest angle, and the middle goes with the middle. So obviously 90 degrees is our biggest angle here. And if you go across there, the hypotenuse 16.3 is the biggest side, correct? All right, that's good. 23 is our smallest angle. And if you shoot across there, 6.4 is our smallest side. That's good. And then 67 goes with 15 as our middle angle and middle sides. That's always a good check. Make sure you're doing it right, okay? Awesome, so we did it. So now let's go on to number 4, and let's do this again using radians now. So using radians, the process is going to be the same. It's just that we're now using radians. So that is going to cause a few differences. So let me walk you through that. So I first do want to find this other angle, okay? And in order to do that, I'm going to subtract out the angles that I have, right? So what I did back here was I knew that 180 degrees was a full triangle. Well, if we're doing radians, what is a whole triangle in radians? If it's 180 degrees, how many radians is that? Well, that is actually pi radians. Remember, our conversion rate is 180 over pi, correct? So that's kind of where they're equal. Pi radians is 180 degrees. Now we need to subtract out the right angle, just like we did over here. The right angle in degrees was 90 degrees. So what's the right angle in radians? Well, we can do a little trick here. We can know that if the whole triangle is 180, then the right angle is half of that, correct? So same thing here. If the whole triangle is pi, then the right angle would be pi over 2, half of that. That's right. Ha, get it? That's right. Okay. Because it's a right triangle, right angle. Okay, and then lastly, we will subtract out the other given angle. So that's going to be 2 pi over 5. So when you're doing this on problems in the future on a right triangle, this part, the first two are actually always going to be the same. The whole triangle will always be pi. And if it's a right triangle, you'll always have a pi over 2 there. And then this 2 pi over 5 is going to be different from problem to problem based on whatever angle they put there, okay? Okay, so now we need to subtract these 3 numbers here. All right, now we do have some fractions in there, correct? So I know this goes without saying, but why don't I say it anyway? When we subtract fractions, we need a common denominator, correct? That's this new thing we're doing now, where we do find a common denominator when we're adding or subtracting. No, just kidding. You've always done that, right? Okay. All right, so this is over 1. So we got pi over 1, pi over 2, 2 pi over 5. So it seems like I can make all of those have a denominator of 10 pretty easily, if you ask me. So this is going to be 10 pi over 10 minus 5 pi over 10 minus 4 pi over 10 which would be 1 pi over 10, which I would just call pi over 10. That is our smallest angle on this triangle. Remember, a bigger denominator does represent a smaller number, correct? All right, so now we got all 3 angles. So now let's start finding some sides here. All right, so first thing I would want to do, pick one of these 2 angles, either 2 pi over 5 or pi over 10, whichever one you want. I'm going to go ahead and use 2 pi over 5. So if I'm using 2 pi over 5, that means that 15 is my opposite. I know that across from the right angle is my hypotenuse, which I'm actually going to call y again. And so that means that this leftover one is going to be the adjacent, which I'll call x. All right, so I'm going to go ahead and find x first. All right, so if I'm going to find x, I know the opposite. I want to know the adjacent. So I'm thinking about O and A, so I'm going to do another tangent. So I got tangent of 2 pi over 5 equals, that would be opposite is 15 over x. So this is another one of those where the variable is in the denominator. So I'm just going to visualize. I multiply the x over here, divide the tan back over here, which means x equals 15 over tan 2 pi over 5. All right, so let's head back to the calculator. 15 over tan 2 pi. And remember on Desmos, if you want pi, you could just type pi, 2 pi over 5. So you can see here that the answer says 683.8. Now, that answer does not seem reasonable considering this triangle, right? That is way too big for this triangle. And that's not the correct answer. But why is it not the correct answer? Well, I'm still in degree mode from the previous question, and we're now talking about a radian. So I need to go into my wrench, switch this back to radian mode, and you can see that answer changes to 4.87. So x is going to be 4.87. All right, now we'll do the same thing for y, or not the same thing, but let's see, I know the opposite and I want to know the hypotenuse. So that sounds to me like a sine. So sine of 2 pi over 5 equals 15 over y. Once again, I have my variable in the denominator, so I'm going to visualize multiplying the y over to the left side and then dividing the sine of 2 pi over 5 back to the right side. So I'm going to get y equals 15 divided by sine of 2 pi over 5. What's really nice about Desmos is that we can just go in here and highlight that and delete it, or just type over it sine. That would be 15.8. All right. Y was my hypotenuse, right? So that is good. I got the biggest side opposite my right angle. And then I got this 4.87 is opposite the pi over 10, which I said was our smallest angle. All right, so that's all good. Okay, this chart, we might do it tomorrow or we might not. I'll let you know. I don't think it's super crucial. Let's scroll down to the next page and we'll just do this one right here, the triangle with the 5 and the 2, and that'll be our last one of the day. Okay, so this one right here says, find the exact value of all 6 trigonometric functions for the angle in the given triangle. So when this question is asked, and we're going to be seeing a lot of this upcoming, okay, you don't need the angle measure. So we don't need to do a cosine inverse here to find out what angle A is. We could if we wanted to, but it really would be a waste of time. Because what we're going for on this one is we just want to know what is sine of alpha. What is cosine of alpha? What is tan of alpha? What is cosecant of alpha? What is secant of alpha? And what is cotan of alpha? That is the 6 trigonometric functions, right? Well, from angle alpha, this is my opposite side. I know across from the right angle is my hypotenuse. And so then I know that 2 would be my adjacent side. So I can actually already find 2 of these, all right? Since I know the adjacent and the hypotenuse, I know that cosine of alpha would be 2 over 5 adjacent over hypotenuse. And if I know what cosine is, then I can always know what secant is, because secant is just the reciprocal of cosine. So now I need to find the other 4, but in order to find the other 4, I'm going to need to know what is that opposite side. Now, if I'm not using SOHCAHTOA, if I don't know what that angle is, how can I find the missing side on a right triangle if I know 2 other sides? Well, little something called Pythagorean theorem, a squared plus b squared equals c squared. Ever heard of it? All right, so what's really crucial on Pythagorean theorem, the hypotenuse has to be c. So I'll put 5 there. A and B are really interchangeable. It doesn't matter. We're adding them up anyway. So I'll go ahead and say A is 2 and B is unknown. So I'm going to subtract the 4 over, since 2 squared is 4. All right, and I got over here, b squared equals 25 minus 4. 25 minus 4 is 21. Do a little PEMDAS there, exponents and then subtraction. All right, and then I'll square root both sides. What's up, Nick?
It's going to come out irrational. It's going to come out as decimal.
You're correct, but I actually don't want the decimal, okay? For these problems, we're gonna go ahead and leave it as a radical, all right? Now, I do want you to check and see if the radical can break down. So remember, we do like 7 and 3. None of those can break down any further. If we have twins, they go outside. If they're loners, they stay in the house. So these ones are loners. So this one's just gonna stay as a radical 21, but I want it written as a radical. All right, so now that we have the opposite side, we can go ahead and fill out the rest of our trig functions, all right? So we know sine is gonna be opposite, so that's rad 21 over the hypotenuse, which is 5. We know tangent then is opposite rad 21 over adjacent, which is 2. Cosecant will be the reciprocal of sine, so it's going to be 5 over radical 21. And then cotangent will be the reciprocal of tangent, so it'll be 2 over radical 21. Okay, good. Now, some of you may be thinking, hey, Mr. Barry, look at these 2 right here, 5 over rad 21, 2 over rad 21. My geometry teacher told me we're never allowed to leave a radical in the denominators. We have to rationalize that, okay? However, I got good news for you. You don't have to do that anymore, all right? Now, was your geometry teacher wrong about that? Not really. In geometry, they do want you to rationalize the denominator, so they want to make this 5 rad 21 over 21. The higher level math you get, the less important it is to rationalize that denominator right there. They don't care anymore. So guess what? You are in a high level of math now. Welcome, you're here, you've arrived. So we do not need to rationalize denominators anymore. We have problems like this on our WebAssign, and you can go ahead and put them like this with the denominator, with the radical in the denominator, it is fine, okay? Awesome. If you do want to rationalize the denominator, it'll still mark it correct. You just don't need to, okay? Awesome, so that'll be our last problem for the day. So just a couple announcements here to finish up. So we got 6.1 WebAssign is due tonight, so make sure you get that done. We're gonna finish up 6.2 notes tomorrow in class. If you'd like to, your 6.2 WebAssign is not due till next Wednesday, but if you'd like to get started on it, you can probably get a lot done based on what we've learned today. So feel free to do that. It's been posted, okay? But tomorrow we're gonna finish up the notes in class because I really wanna do this section together because I think it's really important. But 6.1 is due tonight, so make sure you do that. Let's wrap up with some memes here. So what do we got here? Here's a good one. So you could say it's 90 degrees outside. If you see a cloud like that, it would be 90 degrees outside, okay? Or it would be, you could say it's pi over 2 radians outside. That wouldn't be funny though, because this is funny because 90 degrees can also refer to temperature. So it's a double entendre. See, that's funny, that's comedy. All right, and then my other meme is actually Mr. Barry original created meme here. Let's see if I can grab that one, yeah. All right, what in reciprocation? So this was a popular meme format like 5 years ago. It was like based on the what in tarnation, but then you would like change this. It was a whole thing. But what in reciprocation would be switching from sine to cosecant, since of course they are reciprocal trigonometric functions. All right, cool. That's all I got. Yeah, I agree, Hanukkah. Where's Brian?